Hey everybody, Mr. Morel here, and we're here to talk about quadrilaterals. So for the last several assignments, we talked about triangles in one of the assignments, and then we just talked about polygons in general, and remember the polygons have like lots of different sides. Well, we want to zero in and look at some quadrilaterals specifically, because there are actually some pretty neat features to quadrilaterals that I want you to see. So the first thing that we're going to do is we're going to kind of try to define what some of these words are here. We want to know what a rectangle is, and a square, and a parallelogram, and a rhombus, yeah, whatever. And so to do that, I have kind of some properties for you to look at and to check box when you think that something has that. So when we think about a rectangle, hopefully you have this in mind. It's a shape, it's a quadrilateral that has all 90-degree angles. I don't think all of the sides are congruent with rectangles. I mean, they might be, but it's not true for all rectangles. So I'm going to leave that one blank. I do think that opposite sides are parallel when it comes to rectangles, so let's check that off. Opposite sides are congruent. Are they the same length? Well, yeah, with rectangles, that's true. And opposite angles are congruent. Well, yeah, all of the angles are 90 degrees, so that definitely seems like a true statement. Okay, let's talk about squares for a second. Okay, so a square. Yep, all of the angles are 90 degrees. All sides are congruent. They're the same length. Opposite sides are parallel, for sure. Opposite sides are congruent. Yeah, because all of the sides are congruent, so for sure. And then opposite angles are congruent. Well, yeah, because they're all 90 degrees. It's really easy. Okay, so a parallelogram. Why don't I draw like an extreme version of a parallelogram? A parallelogram might look like this. Oh, I don't like that version. Let me draw another one. Like this. Boop, 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 boop. Like that. That's a good parallelogram. Sorry, it's way off. Okay. Well, let's see here. Oh, I don't think that all of the angles are 90 degrees. They're definitely not in the picture that I drew. So it's not true of all parallelograms. In my parallelogram, not all of the sides are congruent, okay? But, yeah, I do think that opposite sides are parallel. First, that's why it's called a parallelogram. Opposite sides are congruent. Yeah, that's true. Like, no matter how you draw your parallelogram, this side is equal to that side, and that side is equal to that side, for sure. And for that matter, and you can actually use our triangle sum theories. For example, if I connect a line right there and say that these sides are equal, well then I also know that this side and this side are equal to one another. And so, yeah, I think you could say that opposite angles are congruent. And we can use our triangle congruency thing from back on homework assignment 13.2 to help us with that. Alright, a rhombus. A rhombus, the best way to describe a rhombus, I think, is that it's like a square that somebody sat on. So I'll do my best to draw a good rhombus. Probably like that. So, are all 90-degree angles? Not necessarily. Are all the sides are congruent? Yeah, that is true, because it's like a square. All of the sides will be congruent, okay? So we can even mark that up like that if we wanted to. Opposite sides are parallel? Yeah, that's true with a rhombus. Opposite sides are congruent? Well, yeah, because all of the sides are congruent. And opposite angles are congruent? Yep, that's true too. And we can kind of use, like I said, we could use our parallelogram, or we could use congruent sides and things like that to show, hey, this triangle here has the same three sides as that triangle, so it must mean that this and this are the same. And we could have done that the opposite direction too. Like I could have drawn a line like this and said, hey, these are all the same, so those are the same. Yeah, so I'm going to definitely agree with that. Okay. Now, down here, we're kind of trying to take all of our work from the last worksheets, and instead of applying it to lots of sided figures, we're going to do it to four-sided figures, just different looking ones. So my plan here is to do this question, and this question, and hopefully that gives you a hint for what I'm looking for in all of these. So, on the diagonals column, well, we just want to draw diagonals. If you remember, diagonal means we go from one vertex to another non-adjacent vertex. So the only one here is like that. Then I'm going to check this corner and go like that. And then, oh, I've already got that drawn. So it looks like there are 2 diagonals on rectangles. Okay, so you're going to go ahead and do that with the other shapes as well. Now, reflective symmetry. Let's do this square this time. Now, that's our folding lines. Where can you fold this square and have it land on itself? Well, if I remember right, we could fold it here. We could fold it here. We could fold it here. And we could fold it here. So I think I counted 4 places that I could fold that square and have it land on itself. Okay. So, now this is tricky. For rotational symmetry, I'm going to kind of imagine a dot in the middle of this shape. Right smack dab in the middle. And I need to figure out how far do I need to turn this so that this angle ends up on the congruent angle. Because like in order for a shape to land on itself, then I need this corner to end up on a corner that's the same. Well, in this example, it's really easy to see that this is smaller than 90 degrees and this is bigger than 90 degrees. So like, I say that because it doesn't do me any good to rotate this angle on like that corner onto that corner because those are not the same angle sizes. So it seems to me like I need to rotate, well yeah, because above we talked about how opposite angles are the same. So I need to rotate it so that this angle ends up on that angle there. And I could do that twice. So it seems to me like I could rotate this shape 180 degrees or 360 degrees and it would land on itself. Yeah, that seems to make sense to me. Again, it doesn't really make sense to rotate it 90 degrees because to me, if I get a small angle on top of a fat angle, that's not gonna the shape's not gonna look the same. It'll look weird. Okay, let's go on to the next page. Ooh, a rhombus. Which one should I do for the rhombus? Why don't I do a diagonal? Okay, so if I start here, one diagonal is gonna look like that, and then I can't do any more. Another diagonal is gonna look like that, and I can't do any more. So it looks like the rhombus has 2 diagonals. Ooh, and then we get into this world of trapezoids. So a trapezoid is defined because it has one pair of parallel lines. And this is how we show that 2 lines are parallel. And other than that, there's no rules for a trapezoid other than it's a quadrilateral with one pair of parallel lines. So with that in mind, what you want to do is you want to kind of be able to figure out things. Why don't I go backwards this time? So an isosceles trapezoid not only has the parallel lines like this, but we are going to have the same angles at the bottom, and also these sides are going to be the exact same length too. So we've got a lot of good information here. Yeah, so looking at this looking at this trapezoid, let's pretend I rotate around the middle here. Well, it seems like I don't want this wide angle to end up on this small angle. I don't want it to end up on this small angle either. I might try to rotate it to get this angle onto this side here. But it seems like in order for that to happen, and you may want to kind of turn, I can't turn the iPad image, but I think if I were to rotate that 3 times, I'm going to end up with I don't know. It just seems like to get this dot on that dot, that my shape isn't going to look right. It's going to look something like this. So I don't think that that's a rotational symmetry. I'm thinking, and again, maybe you want to try turning your paper a bunch to see how much you need to turn it to make sure you get your long side on the bottom and your short side on the top. I think the only way to rotate this to have it land on itself is 360 degrees. That's what I'm going to guess. Okay, let's look at the trapezoid here. Let's see if we can find some reflective symmetry. Well, I don't know, we could do some general thoughts here. Maybe I reflect on this line, but if that were true, then I would need this angle and this angle to be the same. Well, this is a right trapezoid, so I know that this is a right angle here and a right angle here. And so it doesn't seem like I would want to reflect this angle onto that one. So I'm going to say that's a no-no. What about going the other way? Ugh, same problem. I do have a right angle there, and I don't have a right angle here, so it doesn't seem like that's one of my lines of symmetry. Well, what if I kind of go through the middle? Ooh, this is tricky. Well, I could go in the middle like that, but do you see how, like, this side is shorter than that side? Even if you get these two to be the same, then that one wouldn't be the same. Well, maybe I want to make it so that these top ones are the same. Yeah, like that this side is congruent to that side. Ugh. But even then, I'm going to have right angles here, and they're not going to line up. I don't think that's going to work. Okay, so what if we cut it there? Well, we're running into that same problem. At least one good thing is that this right angle would end up on that right angle right there. But I think the problem is that when I fold it, I'm going to end up with a shape kind of like this. It's not really working out for the other angle. So do you know what? I'm thinking that there are 0 lines of reflective symmetry here. Well, why don't we look at the scalene trapezoid and figure out the diagonals? Well, I love diagonals because they're so simple. I can do a diagonal there and a diagonal there, and oh, it seems like we got 2 diagonals on this trapezoid here. Okay, well, here you need to fill in the blanks about the type of quadrilaterals. So you're looking at either trapezoids or parallelograms or squares or rectangles or whatever. Types of things that fit these descriptions. So which type of quadrilateral had 180-degree symmetry and nothing else happening with it? Which one had 180-degree rotational symmetry and the lines of reflections were the same as the diagonals? Which one had rotational symmetry and the lines of reflections were not the same as diagonals? Which one had lots of lines of... Anyway, I'm giving away too much. Sorry, I'll stop talking about level 4. I know you are dying to do that on your own, so I'll let you. And thank you so much for joining me for this video and for this entire unit. It has been such a pleasure. Our plan is the SAGE test next, so we'll finish reviewing for the SAGE test. We'll do that for a couple of days, and then we'll come back and learn about constructions and then build rockets, and then it's the end of the year. I guess what I'm saying is I think this is the last video that I'm going to be doing with you guys. It makes me sad. I might cry. I might not. I guess we'll never really know. So, make good choices. Bye!